on last night's homework, what I asked you to do was look at a graph and describe it to me using different language, different kinds of language, okay? Or to look at some given information and take that given information and produce a graph. Y'all see how those are like going in both directions, all right? So what we're gonna start on today is getting the information when there is no graph. What I give you is a function. Okay? Now, there's lots of information you can get, all right? Sometimes if you skip something, you still have enough. Sometimes if you skip something, you're missing the piece that makes a difference in getting the proper line data off, okay? So I'm going to show you all the different pieces that you might get. Tonight's homework, I'm going to tell you to get all of them, all right? And then later on, you'll discover that you don't always need everything. So the first thing that you need is domain. You need to be able to look at a function and tell me the domain. You start with hours and hours and hours on that last year. So this is polynomial, and that means the domain is negative to infinity, all the numbers. Yes? Okay. The second piece that I only get this piece of information in two circumstances. One, if it's easy. If I look up there and I go, that's easy, I can get that. And two, if I'm confused about something and I need a little bit more information, then I'll sometimes go and get the x-intercept. But you should be able to get an x-intercept anytime I ask you to. And the nice thing about having the x-intercepts is you've got 2 points. You can pop them on the graph and you know that those 2 points have to be there. Okay, we've been doing x-intercepts for a long time. Okay? Those are both old. You could also get the y-intercept if you wanted to. Another easy piece of information is the y-intercept. I don't usually get that unless I'm completely lost. I just want to get one more thing. Okay? The next thing you have to do is you have to find the derivative. We all know that is sometimes easy, like in this example. Sometimes less easy. I'm going to ask you to structure your paper the same way that I am up on the board, so that everything fits in a way that makes sense. And as you look at it, if you decide on a different structure, then that's a paper you need. You also need to find the second derivative. You need to find them correctly. Okay? The second derivative also easy is, not always easy, it's often easy, right? Everybody good so far? All right, then for each thing, the derivative and the second derivative, you have to determine if either of these circumstances have answers. Is the first derivative ever equal to 0? Is the first derivative ever undefined? You have to determine both of those things. You have to do the same thing for the second derivative. Sometimes you can do that very quickly and very easily. Sometimes it takes a little bit more work. Okay? So if for example, in this problem, take a look at the first derivative, set is equal to 0. And do you actually need to write that down, or do you do that one in your head? Yeah, you can do it in your head. Again, that's okay. I don't have a problem with that. But there it is. First derivative is equal to 0 when x is equal to 3. Yes? First derivative ever undefined? No. So this is a situation where, as I said, if you left this piece of information off, you probably could still get the final answer right. But sometimes if you leave this piece of information off, this undefined part, then you're going to mess up the whole thing. Okay? All right, second derivative. Does the second derivative ever equal 0? Second derivative never equals 0. Is the second derivative ever undefined? No. Okay? All right, then you are going to next determine an interval test, or use an interval test to tell me where the first derivative is positive and where it's negative. You're going to label it, and you're going to do the same thing with the second derivative. This is sometimes easy and sometimes hard. Okay? In this case, it's easy. So what numbers do you need to put on your interval test? You need to put this number right here. Sure. What numbers do we put on the second interval test? That's double prime. Do we have any, what number do we get? Here, okay, no, how you know, do you put any numbers on there at all? Nothing. Okay, like on the rows. No, we do that. Now your interval testing. What are you testing in? You're testing in F prime. Okay, so you pick a number like 2, and you determine if the F prime of 2 is positive or is it negative. I don't care whether you get the number. I just need you to tell me whether it's positive or negative. So when you plug in 2 right here, 2 times 2 is 4, minus 6 is negative, so you can pop a negative right there. Show whatever work you need to show. Sometimes you won't need to show any. Okay? Check F prime of something like 4, or 5, or 10. 2 times 4 is 8, minus 6 is positive right there. That makes sense? So what are you supposed to check for F double prime? There's no numbers on it. Well, that's because I don't care what X is, F double prime is always 2. Yes? And therefore F double prime is always positive. You can put 1 plus up there. Everyone always like looks at that, gets confused. So whenever it's always positive, I use just a handful of them. This is our goal on every problem that you have to do tonight, is to get all of this information on your paper. Yes.
So, in last night, when we were interval testing F double prime, wasn't the first one happening?
Yes, we're going to, our next step, after we learn to gather the information, we'll then take the information and draw graphs.
So that's a whole different interval test?
No, it's the same thing. I gave you some information on last night's homework, or you read it from a graph. And now you're getting the information not from a graph, but by looking at the function itself.
So then why is it positive if it's not a concave graph?
It is concave. Graph is concave.
It's a line.
Okay. So let's back this up. Can everybody listen? Because what Ellie's asking some of y'all, what they y'all from the other thing, is the key to about 90% of y'all's mistakes. And by y'all, I mean the people I taught for the last 2 years. Okay? So, what is this? F of X. Yes? What is this? It's the slope of this. What is this? It's the concavity of this. The word "it" needs to be thrown out of your vocabulary. If you say if it is positive, I don't know what you're talking about. Okay? The second derivative is positive means that this function up here is concave up, not that this is concave up. This is concave up. And that thing right there, that right there is the key to about 90% of the mistakes that are made on these problems. Okay?
And that interval test shows that it's decreasing.
Shows that what's decreasing.
Shows that the function
Yes.
is
Decreasing and then increasing. That's exactly right. Yes? Okay. That's not the last time you're going to hear me say that. Okay. Very good? All right. So that's the process. I could technically stop right there. Yes? Except that sometimes some of those steps are harder, and I want to crunch through some of those problems to make sure that you haven't forgotten some things that you already know. I'm going to remind you of some things that you already know. Yes? Domain. All right, because the denominator can't be 0. X can't be 0. You know that. What else? Do you remember what L of X looks like? Do y'all remember what this looks like? Right? Like this. Yes? What's its domain?
0 to
0 to infinity. So if I take it and pop it into some other function, automatically what becomes part of the domain of that other function? Can't be negative. Yes? Y'all see this? So we got this piece from the denominator. But this piece right here tells us that X has to strictly be greater than 0. So you put those two things together, and it turns out that the domain of this, the actual answer is X has to be strictly greater than 0. Do not plug any negative numbers into anything that you do. Not allowed to put a negative number in here, because if you put a negative number in, you get the natural log of the negative number, there's no answer to that. Okay? All right. I want you practicing doing x-intercepts. I will tell you that this step becomes like an extra step later on. There will be practicing it because you're going to be practicing some good algebra. All right, so the x-intercept is where ln of x over x equals 0, yes? And remember, if you have a fraction equal to 0, that you just set the numerator equal to 0, and we'll pause for 10 seconds while you think about that. They know? One. Know your parent graphs. Yes? You might also notice that ln of x is negative here and positive here. Useful piece of information. Okay, so what do we do after that? Now we're particularly hard. Derivative. So we're going to do g prime. What rule does that require us to use? Quotient rule, or you could change it into product rule if you wanted to. I don't think that's easier. I'll do quotient rule bottom times derivative of the top minus the top times derivative of the bottom over the bottom squared. As I said, sometimes the derivative is more complicated. Clean it up to something that's not quite so nasty to look at, and you get 1 minus the ln of x over x squared. It's your first derivative. This is a good place to check with somebody. The same first derivative I got. If your first derivative is wrong, what's going to be true about your second derivative? It's going to be wrong also. Right? So let's see if you get the first step of your second derivative done. Okay, there's your first step, your second derivative. Yes? Okay. Asking yourself, what are the things I tend to forget in this? Clean it up a little bit. I'll go ahead and clean up a little bit. Arrows for the next step. I'll do this. Add your like terms. The general rule is to multiply out your numerator and leave your denominator kind of alone, generally. A couple of steps later, you get this. As I get to that point, okay? Now, we should be expecting the denominator is to take the derivative to go from x squared to x cubed. That's what we're expecting to happen. It went to x to the fourth. It's kind of a clue that you might need to do something like, look at the top, what do you see in both terms? And the x, so we'll factor one out. And what are we going to be able to do with that x? Are we good? What are we going to be able to do now? Cancel that. Yes. We're going to get g double prime is -3 plus 2 ln of x over not x to the fourth, but x to the third. Okay? Some people, I don't think it makes any difference right here. This is just one of those things you should know. This thing right here, 2 ln of x, could be changed to ln of x squared. Y'all remember that? So it might be a useful thing to do later on. You might or might not need to do that. All righty. Next, we're going to take a look at g prime and ask ourselves, does it ever equal 0? We're going to look at g prime and ask ourselves, is it ever undefined? Those two things. Okay? G prime equals 0. Fraction, so we can do the top. Call it what you remember. The answer is Okay, can we rewrite this in exponential form? Rewrite it in exponential form. I want you to rewrite it in exponential form. What's the base? This is log base what? No, it's not log base 10. Log base e. So rewrite that in exponential form. What's the base? You guys, come on. I know it's been a while.
E to the 1 equals
E to the 1 equals x. Yes? So what's the solution to this? X equals e. Now, in theory, you should have done that faster than that, but now that you know how to get it, next time don't miss it. Yes? Okay. X equals e. Just 2 weeks adding something. Okay? G prime is undefined. What do we put down?
x squared.
X squared cannot equal 0. X squared equals 0. And that's x equals 0. We don't have to worry about that because it's not in the domain. But we have to check for it. Okay? Our domain is greater than 0. We have to check for it. All right, you ready to do the second derivative? Yep. Yep, this one, we're ready. G double prime equals 0. G double prime undefined. I'm going to do this one first. And I'm just not going to worry about it, not in domains. And if you leave it off and it's not important, you don't lose any points. If you leave it off and it is important, you're going to get the problem wrong. Okay? All right. So see if we can get that second one, or the first one. Where's G prime equal to 0? All right, chance. Don't say only again. Now what is it over here? Maybe that's the form. What's the base? E to the power 3/2 equals, there it is, x equals e to the 1.5. I don't know what that is, but it's a little bit bigger than e to the 1. Yes? All right? What? Are you dividing by ln? Okay, so, well, just so you know, dividing by ln would be the same thing as saying you're going to divide this by the square root. ln is a function. It's not a number or a constant. It's a function. It's like saying, oh, I'm going to divide by plus. Or I'm going to divide by minus. And the reason that you're thinking is because it doesn't look like a function. It looks like something you can divide by. Okay? That makes sense? Okay. No? Okay. All right, we're off. Now what?
Now we interval.
Now we interval test. We write G prime. And we write G double prime. You can put these interval tests one above the other. You may find you like that better. I'm just kind of keeping them all lined up.
And you said not just doesn't
Yeah, the reason it doesn't matter is, can you go back to the beginning of the problem, Lake? What was the domain of this problem? Go to the beginning. Everybody go look. X is greater than 0. So, right there. Do not plug any numbers into this problem that are less than 0. Does that make sense? And you put it on your interval test to remind you. Okay? What goes on here? E. Somewhere in the general vicinity of 2.7. Okay? What goes over here? This is, I don't know what it is, but it's bigger than E. Okay? I have no idea what it is. It's bigger than E. Everybody good? Okie dokie. Now, what the heck? How am I going to figure this out? I need to plug in something into my derivative. I need to plug in the number between 0 and E. And it needs to be something that's fairly simple. Okay? You remember what you're plugging it into. You're plugging it into this. All of this. Don't plug it into this, because you're missing part of the problem then. You have to plug it into the whole derivative of it. Okay? So I'm plugging in, that is, what's the denominator always gonna be? Plug in anything in that denominator, it's always gonna be positive. But we still wanna plug it into the whole thing. I'm gonna have to take the ln of something, so I wanna pick a number that's easy to take the ln of. I want to do g prime of some number that I can do the ln of. 1, smaller than e. Or 1 over e, e to the negative 1, you can do that also. Okay, so that's what we're doing here, we can see my derivative. 1 minus the ln of 1 over 1 squared. And you don't actually have to do it all, you just have to know whether the answer is positive or negative. What's the ln of 1? It's 0. And so this is positive over positive, which is 5. Okay? I need to put something easy here that I can plug in to ln and get the answer. Something bigger than e. Anybody know the ln of 3? You know the ln of 10? You know what you know the ln of?
E squared.
You know the ln of e squared. Good. You know the ln of e squared. What's the ln of e squared?
1.
What's the ln of e to the 4th?
Oh, 2.
The ln of e to the 9th. 9. What's the ln of e squared? 2. Okay? ln of e squared is 2. So 1 minus the ln of e squared over e squared squared. Thank goodness I don't really need to know what that is. It's positive. So this is 1 minus 2 over some positive number. This is a negative divided by a positive, which is negative. As I said, the actual steps are not hard, but sometimes a particular step is more complex than another one. Does that make sense to everybody? Are we good with that? Okay, so choosing something that makes your life easier, because you don't know the ln of 3, you don't know the ln of 5, okay? But you do know the ln of e squared. All right, so what are we going to pick over here? 1. Okay, actually, can I show you e to the negative 1? The e to the negative 1 is a positive number. I just want to show you what that gives you. What was my second derivative? I just put that down. 3 plus 2 ln of e to the negative 1 over e to the negative 1 cubed. I just want to show you e to the negative 1 because sometime or another you might need it. Like, what if this had a 1 on it? What if this number right here was 1? You need to get something smaller than 1, and e to the negative 1 fits the bill. Okay? So this is negative 3 plus 2 times the ln of e to the negative 1. Okay, what's ln of e?
Negative 1.
Yeah, okay. And I don't care what this, e to the negative 1 is a positive number. It's 1 over e. It's positive. And a positive number cubed is positive. So what do we have here? What's the top? Negative divided by a positive means that this is going to be negative. Does everybody see how that works? Okay, so now e to the negative, what's e? 2.7, and you're going to raise it to the negative 1 power, which makes it 1 over 2 pi. Okay, fail. All righty, can y'all decide something good to pick on the other side? Yeah, because this is 1.5. Yes, that's 1.5. So you're going to pick e squared, okay? Or e to the 3rd or e to the 4th. So negative 3, 2, e squared. And when you actually do this, you could, go ahead and just put a 2 there. And if you do it enough, you can do it in your head, okay? But you're getting these written down for your notes, yes? These are the ones that people miss. And that's negative 3 plus 2 times 2 is positive over positive, which is positive. Oh, that's example 2. I think that's the worst one. Okay? We remembered a lot of stuff working that problem, though, yes? Remembered a lot of stuff. Great. Some of you are thinking, didn't we just do an E one? No, we just did an LN one. Yes? That first one was an LN. So let's think about, what the domain of this looks like. And I just want to remind you of what this looks like. Because this is T. What does e to the x look like? This. And you put anything you want into e to the x? Yep, anything you want. Multiply times 5, that's fine. And e to the 2x, that's all fine. So what's our domain? Let's go ahead and practice the x-intercept. This is helpful. We might need to do it sometime. And plus, when I show you how to do the x-intercept on this one, you're going to do the easy. So the rest of it's going to be easy. So the x-intercept is 5 e to the x minus e to the 2x, set that equal to 0. And there's a little thing here that I'm sure many of you have forgotten. Okay? Well, that is one way you could do it. I'm not going to say it won't work. It's not the way I want to show you. Okay? So, e to the x times e to the x is e to the 2x. Is that right to that? So that means that e to the 2x is e to the x times e to the x. Agree? And you know, you get a little tiny bit of exponents in Algebra 2. You spent a good bit of time on them last year, but it's still one of the things that's one of the newest tools in your toolbox. We don't feel as comfortable with it as we do with square roots, right? Those come pretty easily. But this is a piece, this is a little tool that's going to show up. What can I factor out of this? E to the x. And I think that's not immediately obvious, and you can work with e to the x and e to the 2x a little bit. So, e to the x equals 0, or e to the x equals 5. Yes? It up, you'll do better. You really will. Okay? Right. Here's your graph, here's e to the x. Does it ever equal 0? Nope. What happens? How do I solve this? Take the L on both sides, or change it to L in form. Okay, take the L on both sides. If you take the L on both sides, that gives you x. I don't know what the natural log of 5 is. I haven't got a clue. It's a number. Okay. In my day, we looked it up in a table in the back of our book. It was horrible. It had 4 decimal places. It was awful. In your day, you punch a button on the calculator or 2, and it tells you the number. So very good. Okay, so that's going to help us now that we know how to do that. Let's get the derivatives taken. And we will be much faster at the last couple of steps on this. You really can skip the x-intercepts sometimes. It's really not something you always have to do. Okay, good to do it tonight because it's good for you. Okay, first derivative, come on. 5, no, it's on the paper. You should sit up when you're sleeping. No. You're all hunched over and it's hard. Okay, that first derivative wasn't particularly hard, right? Everybody get this? Everybody remember that times 2? Okay, so I forgot what h was. 5 e to the x minus e to the 2x. So the derivative of e to the x is e to the x. The derivative of 5 e to the x is 5 e to the x. The derivative of e to the stuff is e to the stuff times the derivative of the stuff. Yes? That's chain rule. Okay? Times the 2. Right? Okay.
Times whatever element.
That's long. Alright, so second derivative, if you can get first derivative on this one, the second derivative should be easy. The derivative of 5 e to the x is 5 e to the x. The derivative of 2 e to the 2x is 2 e to the 2x times 2, which gives us minus 4 e to the 2x. Okay? So what I want you to do now is set this one equal to 0 and solve it. There's no place where it's undefined. I'm going to write it down anyway so I don't forget. I'll set this one equal to 0 and solve it. we did for the x-intercept, it's the same idea, okay, same concept.
Can we know that they don't have a denominator?
Well, that's one of the ways it can be undefined, also if you have trig functions, some things can be undefined, and also if you have radicals, square roots, fourth roots, even roots, you can have things that are undefined, okay? But there's no piece of this that's undefined, either the x, either the so this is just like we did for the zeros at the beginning of the x-intercepts, we're going to factor out an e to the x. Like that. And it's perfectly natural for you to still feel uncomfortable with this. That's what I'm trying to tell you. That's why I'm giving them to you, because you haven't been doing them since the 9th grade. You've been doing square roots since you were in the 6th grade. But you have not been dealing with e for very long, so you need a little bit more practice with it. E to the x equals 0 never happens. I'm not doing that. I'll get something out. 5 halves. E to the x equals 5 halves. And y'all look at that still and you kind of go, oh,
Is it a negative?
I don't think so. Negative 5 divided by negative 2.
Okay.
Okay, you take the element of both sides. The same thing as writing it in log form. So, take the element of both sides, you get x equals the element of 5 halves. I don't know what that is. It's the element of 2.5. It's a little bit before the element of e. It's just some number. You could write the element of 5 minus the element of 2. That doesn't count me. I don't know what the element of 5 is or the element of 2 is, but there they are if you need them. Does that make sense? Okay, can you do the same thing for the second derivative? Okay? Are we good? Are we good now? Okay, I'm done. No, you're not done. What's the last thing you're going to do? Integral test. Okay? H, is that what I did? If you line these up, you would need to, I'm going to just show you, you would need to make sure you put them with 5/4 before 5/2, okay? But I kind of like them side by side, and then sometimes I put them below and above. That's going to be your choice, as long as it's on your paper somewhere, and as long as you can work with it, it really doesn't matter. Okay, so here we go. We got to pick something to plug into our function. What are we plugging it into? Plugging it into this.
Is there any reason you did 5 half and 5 half not L?
Because I'm wrong. This is not 5/2, that's wrong. This is the element of 5/2. So y'all make sure that you do not copy my mistake, please. Thank you. Okay? So, I don't know what the element of 5/2 is. But element of 2.5. So, tell me something that I could use. 1. And let's see if 1 helps us. Let's find h prime of 1. So go back up and look at h prime, or, look at the factored form of it. You might like it like this. That might help you. In fact, I think that's what I'm going to use. So e to the 1 and 5 minus 2e to the 1. And I'm not sure. Are you sure? Actually, I don't feel that bad about it. E is what? You mean, E is 2.7, right? So 2 times 2.7 is bigger than 5, isn't it? 2 times 2.7 is bigger than 5, because 2.5 times 2 is 5. So that means 5 minus something bigger than 5 is negative, and E times the negative is going to be a negative. I just want to show you an alternate here. You could have done h prime of the element of 1. And you're thinking, why in God's name would I do that? Okay, so let me just show you. E to the ln of 1, 5 minus 2e to the ln of 1. And what is e to the ln of 1? It's 1. And so what is e to the ln of 1? It is, I'm going to get a different answer. Whoops. So something's gone wrong. Oh, you know what? Here's the reason I don't want to use, what do we use here? I don't know what one, I'm sorry. We didn't do anything wrong here, it's just that I don't know what the element of 5 halves is. Somebody comes to me about a funny calculator, what's the element of 5 halves? What is it? Yeah, 1 is over 3. Do y'all see? So, ugh. I'm gonna reason not to do that. I had it in the wrong place. Because I don't know where 1 is. I don't know whether 1's on this side or that side. Okay, so this is the better route. In fact, I made myself mess up. Oh, that was a good one. Let me call that mistake. Okay? Then we know the other side's negative, but 1's not a good thing to pick. Why is 1 not a good thing to pick? Because I don't know where it is. Okay? I'm not familiar enough with my LNs. Okay, so what would we pick on the other side since we don't really know that 1 is good? Let's pick the ln of, this is the ln of 2.5. How about the ln of, what's bigger than 2.5? 3. So we'll pick the ln of 3, something bigger than the ln of 2.5. Y'all see? Let's look at how that's what's gonna happen when we put the ln of 3 in these places. This is getting comfortable with the arithmetic of natural logs and exponentials. What is e to the ln of 3? It's 3. Okay? Alright, so that's a little bit. Alright, I'm not going to work the next one. It's basically the same. We're just going to decide what would we pick, and then we need to get to the last example. So what would we pick for this one? What would be smaller than the ln of 5/4? This is the same thing as the ln of 1.25. Yeah. So we're going to pick the ln of 1, and then on the other side, we're going to pick the ln of 2. Does everybody see how that works? Okay, and you would need to crunch through that in the same order. I'll say blah, 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 and this answer turns out to be positive, and this answer turns out to be negative. Just because this is really a repetition of this kind of the same kind of work over. Okay? And we need to get to the last example. Okay? Woo. You want to stand up and stretch for just a second? Don't leave. No. Shannon's lucky because when she watches these, she can just hit pause. Yes? I hope so. Okay. Back into slightly more familiar territory. Okay. So this problem is here for a couple of reasons. One, I need to make sure you haven't forgotten what it means to say x to the 2/3. Okay? Y'all remember what that means? What is it the same as? Square root of x. I don't put the square on the outside. You can put it on the inside. Whichever one makes you happy, but on the outside, inside, either one of it's fine. You just need to remember. So, if it's a cube root, am I allowed to plug any number into it? Can you take the cube root of negative numbers?
Yeah.
Yes. So if it's a cube root, then we don't have a domain issue. If it had been x to the 3/2, that would be a square root, and we would have domain issues. Y'all see? So that's possible. That might happen. Okay. So domain. Oh no. Okay. X-intercepts. X to the 2/3 minus 1 equals 0. So let's crunch through that and make sure you haven't forgotten how to solve that. Okay? X to the 2/3 equals 1. And I think you just need to like convert this in your head. You know what What is it I need to get rid of? I need to get rid of the cube root. How do I get rid of the cube root? Cube it. So I'm gonna cube both sides. You can do this in one step or two. I'm just doing it in one step to make sure you see where everything's coming from. Got rid of the cube root. Now I need to get rid of the square. What do I have to do? And when you take the square root of both sides of the equation, what do you have to remember? Plus or minus. So there are two x-intercepts. One times 0, negative 1 times 0. Okay? I'm glad I'm reminding you of all these things.
How many of these are on?
Okay? So f prime of x, not hard. F prime of x, easy. Take the derivatives, easy. Negative 1/3. Okay? Let's go ahead and do f double prime. So 2/3 times negative 1/3, x to the what? Negative 1/3 minus 3/3 is? You gotta be able to add 1 or subtract 1 from a fraction. Negative 4/3. Negative 1/3 minus 3/3 is negative 4/3. Okay, you'll be able to do that if you weren't so. Okay, now, both of those things are fine, but I don't like the way they look. I don't wanna work with them like that, so I'm gonna clean it up into something that makes me a little bit happier. You wanna write cube root? Then you can write cube root, okay? So I'm gonna put the negative 2 on top and the 9 x to the 4/3 on the bottom. Are there any questions? No? Okay, what do we do next?
Where does equal 0?
What is what equals 0?
Where is f prime equal 0?
Yes.
And where does f prime undefined?
Correct. So f prime equals 0, f prime undefined. Sometimes they're hard. The last two problems we did, this part was a pain in the neck. For this problem, this part is easy. Where is f prime equal to 0? Never. Okay, it's where 2 equals 0, which doesn't happen. Yes? Where is f prime undefined?
That's what the 130.
There's where 3x to the 1/3 equals 0, which is where x equals 0. 1, 0. Okay? This is the first time we come up with one that has f prime undefined. Okay? Let's do the same thing for the next one. F double prime equals 0. And f double prime undefined. F double prime equals 0 where? Nowhere. F double prime undefined. X equals 0 again. Are y'all okay with this one? We'll be going from here to here? Yes? Okay, so a little helpful hint. If f prime is undefined, then f double prime will be undefined at the same place. Okay? And if f is undefined, f prime and f double prime will also be undefined. It should happen every time. Okay, here we go. F prime, all real numbers. F double prime, all real numbers. What do I put on here? 0. Is it flat? Is the graph flat? Nope. Something else is going on. It's not flat. Y'all see? We'll get to the graphs later. Okay? And on this one, also put the 0. Alright, so now I need to make sure you can plug numbers into things with exponents like 1/3 and 4/3 and not mess up. Okay? Any negative number, put it in here and take its cube root. The cube root of the negative number will be a negative number. Yes, you need to write that down. Is that something you're going to remember? The cube root of a negative number is a negative number. Okay? And 3 times a negative number is a negative number. And 2 divided by a negative number is a negative number. What do you do in the last problem? Yes? As long as you don't forget it, you're doing some more. Positives. Plug in a positive number. The cube root of a positive number will be positive. 3 times a positive is positive, and 2 divided by a positive is a positive. Okay? That's double prime. You take a negative number, and do the cube root of that negative number, it will be negative. And then if you raise that to a fourth power, it will be positive. Y'all see that? Okay? So this denominator right here, no matter what, this denominator will be positive. The numerator every single time is negative. So on both sides of this, it's negative. So we have reviewed a good bit of algebra, okay, and pre-calc of techniques that you use in algebra and pre-calc. I'm not by any means going to say I've reminded you of everything you're supposed to know. I'm going to remind you that you're supposed to remember everything you ever learned in Algebra 2 and pre-calculus. Okay, okay? All right, let me turn this off. Hi, Shannon.